Hello, my name is Rich Howard, owner of Architectural Builder Supply. In this video is to bring you a closer look at the Bommer number BB5014-507-600. This is one heck of a hinge. It's a confluence of being heavyweight and ball bearing and wide throw and in a prime coat finish. Let's take it out of the packaging and take a closer look at it. That's the hinge when it's folded in half. As you can see, it's a pretty big piece of equipment. That's a Bommer 5x7 wide throw and a heavyweight and a prime coat finish. And a dissection of the part number is what we would want to do to properly understand what this hinge is actually all about. Okay, BB5014. So we'll put that down. By the way, it weighs about 2.33 pound. At least it does with its screw package, which we'll get to. So let's dissect the part number. BB stands for ball bearing. There are 4 bearing packets on this hinge. Okay, that's because it's a heavyweight, and we'll get to that in a moment. But it's a ball bearing hinge. These exposed bearing packets. It's a 5-0, and that does mean full mortise. You can see from the swag on the hinge leaves here, right, the tip of my fingers, that bend right there, that when the leaves are brought parallel, they're meant to be mortised flush to the edge of the door and frame. Okay, that's the swag, and they changed the swag on the hinge leaf to account for different types of hinges. The most obvious example would be full mortise versus full surface. If this was full surface, there would be no swag on those hinge leaves that you see there. There'd be no bend on them. They would just be flat. It's a 5-knuckle hinge. You can see why it's a 5-knuckle hinge. It is a wide throw. That's what the 1 in the part number means. It's a wide throw hinge, meaning the hinge is wider than it is tall. This is a 5, we're going to jump over the 4 in the part number to talk about the wide throw. This is a 507. That means that it is a 5-inch tall hinge and that it is 7-inch wide. And this is a particular hinge for a certain application. And you would use a wide throw hinge when you need to accommodate a particular clearance. We'll do an extended discussion of wide throw. Before we get to that, the 4 in the part number means a couple of things. Means it's made of steel, and that it is a heavyweight hinge. And a 5-inch tall hinge should be 190 thousandths on a 5-inch tall heavyweight. And my caliper tells me 0.192. 0.192, so certainly within range. Yeah, 192, 193. Okay. Now, back to the wide throw. Why in the gospel would you need such a huge hinge like this? Lots of reasons. And let's switch to the screen view so that we can talk about those different, or a couple of different reasons. Now, this is the item that we're looking at. It's a 507 or 5x7, and that why you would use such a wide hinge would be for a couple of reasons. You could literally have a frame condition where that's your hinge, your vertical axis of pivoting, a couple of hinge leaves there. An artist I'm not. So when you get that door out to 90 degree, you get the door rotated out to 90 degree, okay, no big deal. But when you get that door rotated out to 180 degree, now all of a sudden the dimension from the center line of the hinge pin or the vertical axis of pivoting is all of a sudden very important. Where that is in relationship, this way or this way, is all of a sudden pretty important because of what you might have happening inside here. Okay, so the vertical axis of pivoting and its distance as measured from the face of the frame, or the door, let's say, conspires to tell you what size width of hinge that you require. So in a case like this, let's assume, for comparison's sake, that the client would require a 5-inch tall hinge because it's maybe an unusually heavy door that is 1 3/4 inch thick, or maybe a 5x5 hinge, just typical for 2 1/4 inch thick doors, except that they have some sort of a condition, as in I have thick molding outside here that I need to move my pivot point out this way a bit to get the door to go to 180 degree. Okay? Or another condition that you would have, so unusually thick casing is why you would do that. Another condition why you might need to do that would be because, let's say that you had an unusual inset in the door. An inset is the definition of inset is the dimension from the face of the frame to the face of the door. Okay, a typical inset would be less than 1/8 of an inch, maybe 3/32 of an inch. Well, what if it was 1 inch? You could have that. You could have that most certainly, because you might have jam extensions that have been applied to your frame because you had wood doors and frames made, and the frames were for 4 9/16 walls, but then it was discovered that the walls were actually 5 3/4 thick, so they added a jam extension. A wide throw hinge would work to solve that sort of problem. Okay, you could do that. If you have older home construction, when I mean older, I mean 19th century, 3-story building, yeah, those first floor walls are going to be pretty epically thick. And what you're going to see in that sort of construction is that you have a wood frame that's, 18-inch thick. Well, they're not putting the doors out here. They're putting the doors quite in the center of the opening, and you will see some epically huge hinges in those applications. You will see it. The original state capitol building of the state of Iowa, full of them, just like this. A very old building, 19th century construction, before structural steel, very thick walls on the first floor. A couple of good reasons. Another reason that some people will get into really thinking about what they should use in terms of hinges are going to be when they have a set of 4 doors. Okay, and what they want to do is take this door and go like this. So now it's going to end up being like this. So the hinge, to get this leaf to move to here, the hinge over here is going to be a pretty standard leaf. But now what I want to do is I want to take both of these leaves and I want to get them to go like here. Okay, I'll have a hinge over here. My hinge is going to be here. So I really need to think about what sort of wide throw hinge I need to be able to get this whole stack now folded out of the way. This goes here, ends up looking like this. Okay, now you can do all that math. It's not difficult to do. And let's take a look at the manufacturer's page. That link is here, where we can get to the Bommer product catalog. And let's see if they have a formula for wide throw hinge. I don't want to just recite it from memory. I want to go over it while you're looking at the formula. It is indeed in the catalog on page GI 6. So this would be a great document to use in order to figure out exactly what size hinges you're going to want to be using. So the formula is doors up to 2 1/4 have a 1/4 inch back set. Doors over have a 3/8 back set. Okay. When the width of a hinge is greater than the height, it is termed wide throw. This hinge is used when additional clearance throw is necessary to clear trim or wall conditions. Okay. So That's a nice overview. But I want a formula. Okay, unfortunately, I don't see a formula. So here's the formula. Here's the formula. So it's door thickness dt minus backset, hinge backset, times 2. Okay. So door thickness minus the hinge backset times 2. Let's say 1 3/4 minus 1/4, because that's what their formula said for backset here, times 2. It's going to be 3 inch, right? 1 3/4 minus 1/4 is 1 1/2 times 2 is 3 inch. So we know we have 3 inch. We're going to carry that 3 inch value with us. Plus clearance plus inset. Okay? So inset's easy to measure. Face of the frame to the face of the door. Clearance is also easy to measure. When that door is at 180 degrees, what do you need to account for there? So if we go with a 1 inch clearance, and let's just say 1/8 of an inch inset, we're going to be at a hinge that the math would be 4 1/8. And you would then round up to the next widest available hinge, which could be 4 1/2 or it could be 5. Well, obviously this is the value, the clearance, that is really affecting us. Let's say that clearance is 2 inch. 3 plus 2 plus the inset. Now it's 5 1/8. Okay. Use the next biggest hinge. That could be 5 inch, it could be 6 inch, whatever you think will work. Let's say that your clearance is 2 inch and that your inset is 1 inch. 3 plus 2 plus 1. Now we're at a 6 inch hinge. So now you're starting to see where this 5 inch hinge could come into play. You know, you could easily have 1 1/2 inches here, and you could have 3 inches on the inset. 3 plus 1 1/2 inches plus 3. I mean, that's bigger than 7, but 3 plus 1 1/2 inches is 4 1/2 plus 3 is 7 1/2. You could easily do a 508 hinge as well, a 5x8. So this is how you determine what you're doing. And you're going to also use that same logic, obviously, when you are laying out this type of scenario. And this type of scenario happens more than you might realize. I can think of 3 relatively recent incidents where I've come into this. Had a client with an application where they ordered, whoever specified the hinges did a horrible job at specifying them because they didn't understand what was needed for the job. So they ordered a bunch of 6x6 hinges and tossed them everywhere because the client wanted to stack those doors the way in which we're discussing. The problem is they're getting door sagging occurring, and that's a great example of what we're talking about. They're getting door sagging occurring because I didn't supply the hinges. The client came to me for help. I think it's for 2 reasons. Hinges were the wrong hardware to use. I would have used floor pivots and intermediate pivots. Here, and a floor pivot. I would have used, depending on this height, I would have probably have used just 3 intermediate pivots. I'm going to carry the majority of the weight on the floor and reduce how much movement is coming out of the opening in this direction. But because of gravity and because of how unnecessarily wide the hinges are, they're 6 inch wide. They did not need to be 6 inch wide over here at all. I mean, I don't know how thick these doors are. They don't appear to be anything other than 1 3/4 inches. I would have been using 5x4s. I would have gone with the most narrow hinge possible to stack those doors tight to each other. Now, you do have this raised molding that needs to be taken into account, and I don't know what that projection is, but that would be put into the calculation. So figuring the proper, I mean, this just, it looks awful. The reason they put these there is so that they could match these heights over here. But in order to get these doors to stack, and they're stacking the wrong way as well. You know, they've got them stacking to the exterior. But the point of the matter is, this is an example that I've just really brutalized on unnecessarily. But the truth of the matter is, it's important to understand that there's a formula that exists, and getting it done correctly can be done in Manhattan, probably about 57th Street, between 5th and between 5th and 7th. There is a, it's you know, it's full of businesses. That area's got a lot of residential, and they literally have, here's what they have. They have 4 doors. This door goes here. Those 2 doors go here. I've got that wrong. This door goes here. These 2 doors go here. This door goes here. All of it stacks this way. And it was just, wait, did that work? No, it doesn't work. This goes here. This goes here. Stack it here. Stack it here. Stack it here. Stack it here. A beautiful, and I didn't take photographs when I was standing in front of it, and I've gone back to Manhattan, and I couldn't find where the doors were. I spent an hour walking up and down those streets. I was thinking, anyway. So a beautiful example of how they increased what they needed, what they needed to have in all of these instances to achieve it. And it was beautiful. Really, really. Some person sat down and did the math, and it looked just really beautiful. What a great use. Now, the problem is this, and it didn't appear to be a problem. You've got a lot of force hanging out there. You got, these doors were not really wide, but I bet they were every bit of 2 foot, if not closer to 2'6". So you had one hell of a set of hinges over here holding the weight of what was an exceptionally wide door. But it worked. Now, they may have had a caster underneath here, and I certainly would have recommended a caster. That's very common on very, very heavy, thick, heavy doors. Okay, that would have been a great example for a pivot, but this was a concrete drive, steel C-channel frame, large undercuts. These were going to be butt hinges, and they were huge. They were very, very heavy, large hinges, and it just looked great. I would have recommended a caster out here, but again, the problem with the caster is the uneven floor. Okay, so there you go. That's what we're talking about in that regard. So that is the formula. We're talking about wide throw hinges. Now let's see. 507, you can get to, and they can do wide throw up to 8-inch wide. I'm not aware of any manufacturer, any hinge manufacturer that will do wider than 8-inch, but you can do wider than 8-inch. I've quoted things as wide as 12-inch, but they get outrageously expensive. It can be done, but they are commissioned pieces of hardware at that point. You can see what a 5x7 costs. Okay, so let's move on. 600, that means prime coat finish. Let's switch back. Well, actually, we'll just stay on the camera view. 600 is the prime coat finish, which means that it is painted a primer, is what it is. Bommer is very proud over their plating facility. They're very proud of their plating facility. They have a separate facility, and they can plate 32 or 34 different finishes. We have listed 600 for prime coat, and these are all BHMA codes for steel-based product. 600 for prime, 632 for polished brass, 633 for satin brass, 639 for satin bronze, 640 for oil rubbed, 643 is a satin bronze blackened, 651 polished chrome, 652 satin chrome. There are some obvious ones missing. They can do it. Satin nickel, antique nickel, polished bronze. They can do that as well. And then it would be time to talk about how to break up these items, how to look at other options in this regard. And let's go back to the manufacturer's page, back to the product catalog, which is here. And we will get to the matrix by which these hinges are determined. Okay, BB stands for ball bearing. 5 is a 5-knuckle hinge. That's full mortise. We have a 1 down here, so it's a wide throw. And then we have a 4, which means it's a heavy weight on steel. And you can see how you can change those variables. You want stainless and, you want a stainless base material, a brass bronze base material, and a standard weight, etc., etc. You just play with those numbers, and they're all listed here. Sizes are listed here. Options are listed here. Decorative tips. These hinges were not ordered as removable pin, non-removable pin. They're just standard removable. Anchor hinges, that's a different conversation, as are electric hinges. And then your finish codes are over here. Okay. Now, while we are on the screen view still, extended description information, let's just go to the cut sheet, which is really a template. This will be appropriate for 5-inch tall hinges that are 4-inch wide, 4.5, 5, 6, 7, and 8-inch wide. Really what's changing is what Bommer calls the A dimension, which is the edge of the leaf to the swag line. Okay, but otherwise the location of the holes will always be consistent. This document's what's called, it's a template for template hinges, but now we've just used the word 2 different ways. The document is a template. It's a dimensional drawing. But it's a template hinge, meaning that the location of the screw holes is placed in accordance with the template location for a 5-inch tall hinge. What that means is every manufacturer that observes template locations will give you the identical dimensional properties, which is handy because you might want to buy doors prepped for hinges from your favorite wood door supplier, hollow metal frames prepped for hinges from your favorite hollow metal frame supplier, hinges prepped for 5-inch template hinges from your favorite hinge supplier. And if you order it all to the template pattern, they're all going to match. That's really handy. And there are always these dimensions. Okay. Rest of the template will give you columns on base materials, steel, brass or bronze, and stainless, and you can see how that last digit changes. We're dealing with the BB5014 507, so our A dimension is 1 1/16. And a lot of people want to know that information. Okay. Obviously, the edge of the leaf to the center line will be half of the width. And there you go. Some people will ask for the diameter of the barrel. I just don't see why that's necessary. Back to the item we're looking at. Some options are talked about here. Decorative tips. Let's switch back to the camera view and we'll wrap up this video. Now, in terms of the decorative tips, this is what's called a button tip. The tip that's on here, think of a button. It's called a button tip. You can do ball tip. Ball tips are going to be by far the most common of decorative tips. Urn, acorn tips, steeple tips are available. Hospital tips can be done where that tip is ground down gracefully to prevent someone from hanging something on this, from looping something over that hinge barrel. That becomes what we would call ligature resistant at that point. You don't want anything to be able to hang on that tip, so they'll grind those down. That's called a hospital tip. Ligature resistant. Brass pins, stainless pins, this is going to be just made of steel. Now, in terms of the security options, this is a removable pin. You can take a pin punch and force that pin out should you need to. I do. When I hang doors, I'll put the leaf on the door, I'll put the leaf on the frame, I will bring the door to the opening, partially open, get the knuckles, get a hinge pin in there, and you're good to go. That's why I separate the leaves. That's why I personally do it. You can order non-removable pin where there'll be a set screw drilled and tapped into the barrel of one of these hinges. A groove is cut in that pin so that when you tighten that set screw, it will seat inside of that groove, preventing you from driving it out, all but preventing you from driving it out. They have security stud and then maximum security stud. Security stud is a disc that's applied to the leaf with a hole over here so that when you close the leaf, you can't separate them. The Miami International Airport has security stud hinges from another manufacturer and non-removable pin. The doors are held open and it's obvious to a Hinge person that that's what they have. So when the doors are closed, you can not only not drive the pins out, but if you were to, you then can't separate the leaves because of that stud sticking into that hole. Maximum security stud is when they put those posts into the hinge leaf on the door and the hinge leaf on the frame. So same scenario. Reverse, that's when you're going to prep the backside. Your hinge will have the prep on the backside. Radius corners. I've done weird hinges for people with 5/8 radius corners. I've done 5x5 heavyweight. They may have been made of steel. A gentleman in the Netherlands had some patio doors. He had 5x5 American hinges. He was replacing them. He was replacing the hinges because of a finish issue, I think, but needed radius corner. Not a problem. They're going to give you a radius corner. Quarter or 5/8 is what they'll do on here. Okay, so in conclusion, actually not quite yet. This is going to include screws. These hinges are packed with all wood screws and all machine screws. That's not necessarily what I would expect to always see, and I wouldn't count on it. At the time of order, specify the screw type that you want. All wood screws, all machine screws, half wood, half machine, whatever is going to be necessary. What you don't want to do is go to the job on a Saturday morning to find out you're missing half of your wood screws. Specify that in the comment field when you order them. No reason for there to be any sort of failure of having the right equipment. They also include cardboard shims. You need to take that door, tip it a little bit this way, tip it a little bit this way. You can. The shim is in there. If it's a fire-rated door, do not use cardboard shims because it's expressly prohibited. You will need to use steel shims, of which, of course, we can provide you. The last thing I'd like to point out to you is the Bommer logo. Made in USA right above it. A fact that Bommer is quite proud of, as am I to represent them. They are the only hinge manufacturer that manufactures exclusively in the United States. But everything that's brought into the plant, and I've been to the plating plant and the hinge plant, everything that's brought into the plant is domestically manufactured as well, meaning steel, the other parts that go into hinges. I can tell you that after having visited Bommer, I have a very new appreciation for what it takes to manufacture hinges. I've seen hardware made in the past. I have seen continuous geared aluminum. Hinges assembled, that's no big deal. That's just assembly because that's all extruded. Cutting and extruding and cutting. I have seen hollow metal doors and frames made many, many times. And making steel doors and frames, wood doors, I've manufactured wood doors. I'm intimately familiar with that process. That is all child's play compared to what it takes to make a hinge. I have a new appreciation for it. If you have any questions on the Bommer BB5014 hinge, 507 and a 600 finish, or any other Bommer product, please feel free to reach out to us. And thank you.